Hello, everyone. Welcome to another edition of Chemistry Focus. In today's class, we are going to examine the October-November 2021 Cambridge IGCSE chemistry questions. The duration for this paper is 45 minutes. Without much ado, let's get started. Okay, the question one. An experiment is set up as shown. Cotton wool soaked in ammonia, cotton wool soaked in hydrochloric acid. After several minutes, a white ring of ammonium chloride appears as shown. Which statement explains the observation after several minutes? Okay, the first option says ammonia gas diffuses faster than hydrogen chloride gas because its molecules have a lower molecular mass. Hmm. Is anything right with that statement? Ammonia gas diffuses faster than hydrogen chloride. Why? The molecular weight of ammonia, NH3, is 17. How? Nitrogen is 14 plus 3 atoms of hydrogen, which totals 17 grams. If we do the same thing for hydrogen chloride, it is 1 plus 35.5, which equals 36.5 gram per molecule. Out of these two, ammonia is lighter or less dense than hydrogen chloride gas. Therefore, the speed of movement, the rate of diffusion of ammonia is faster than hydrogen chloride. Definitely, ammonia gas moves faster due to lower molecular weight than hydrogen chloride gas. That is just the reason for this. In a capillary tube where diffusion is allowed to take place from the region of higher concentration to the region of lower concentration. So at both ends we have higher concentration. Okay, now diffusion taking place involve the lighter gas traveling faster than the heavier gas, and that is the reason for the first option. The reason for the first option, option A is actually very correct. But let's quickly look at the other options so that we can conclude on the first question. Ammonia gas diffuses faster than hydrogen chloride gas because its molecules have a higher molecular weight. This option is wrong. Ammonia gas diffuses slower than hydrogen chloride gas because its molecules have a lower molecular mass. This equally is wrong. Ammonia gas diffuses slower than hydrogen chloride gas because its molecules have a higher molecular mass. Okay, this last statement is equally wrong. So we stick to the first statement here that ammonia gas diffuses faster than hydrogen chloride gas because its molecules have a lower molecular mass. Okay, the first question. Second, rather, a student put exactly 25.00 centimeter cube of dilute hydrochloric acid into a conical flask. The student added 2.5 grams of sodium carbonate rather, and measured the change in temperature of the mixture. Which apparatus does the student need to use? Okay, if you look at the unit that we have here, the first unit has to do with the volume of dilute hydrochloric acid. And if we take a look at some of the apparatus that is used in the chemistry laboratory to measure volume, uh, the burettes, the pipette, the beakers can be used to measure volume. Okay? Now, if we examine those apparatus closely, the only apparatus that can be used to measure in decimal places is the pipette can be used, the burette can equally be used, but on this note, we stick with the option C. Why option C? The option C has taken care of the weighing of the mass because the student added 2.5 grams of solid sodium carbonate and only a beam balance can be used to measure the weight or the mass of the substance. Then for the volume, the pipette, we go with the pipette. Lastly, for the temperature, we use thermometer. And that is the reason why option C is the correct option. Let's look at option A, balance, okay, measuring cylinder and thermometer. We don't use the measuring cylinder to measure the volume of the hydrochloric acid into a conical flask. And option B, balance, pipette, stopwatch. We are not measuring time, so we don't use this. We don't use a stopwatch for measuring temperature. The last option, the burette, pipette. These two options, these two devices are only used to measure volume. So with this option, the mass of the solid is not taken care of as regards measurement. Therefore, we stick with option C, which is the correct option. Now let's go to the third question. A student separates sugar from pieces of broken glass by dissolving the sugar in water and filtering off the broken glass. Okay, now the apparatus we have here, the setup indicate that the bigger solid, the bigger particles are the broken glass and they are trapped on the filter paper because they are bigger than what could pass through the filter paper. Now, dissolving the sugar in water. This statement shows that sugar is soluble in water. And definitely, if sugar is soluble in water, we are definitely going to have a situation whereby the solute plus the solvent giving us a solution, a solution. In other words, a sugar solution is formed. Now, the sugar solution is the only component of this mixture that will pass through the filter paper as our filtrate, collected as filtrate. While the glass base, the broken glass, will be trapped on the filter paper as the residue. Now, the question is, what is the filtrate? Broken glass only. This is wrong. Broken glass and sugar solution. This is typically wrong. Pure water. This is wrong. The correct answer here is sugar solution. Okay. And now let's move to the fourth question. How many protons, neutrons, and electrons are there in one atom of the isotope 27, 13, Al? This is aluminium. And the atomic number or proton number is 13, while the mass number is calculated as 27. How? Let's take a look at the formula. For the mass number is the summation of the proton number and the neutron number, right? Now, the proton number is also known as the atomic number, meaning that the proton number here is 13, while the neutron number is unknown. But according to what we have here, the mass number is 27. Now, by collecting like terms, 27 minus 13 give us the exact number of neutrons. Now, 27 minus 13 gives 14. Therefore, the number of neutrons here is equal to 14. Right. Now, let's check the option that is exactly as we indicated in our calculation. Proton is 13. Yes, that's fine. That's the atomic number or the proton number. Okay, the neutron number is 13. Okay, with this, we go against the first option. The option here is irrelevant. Okay, if you look at option B, the proton is 13, right, fine. We calculated 14 for the neutron number, that's fine. And the electrons is 13. Okay, this is right because for a neutral atom like aluminum, the total number of proton is equal to the total number of electron. And that justifies option B. But let's take a look at other options. For the proton, we have 14 for C and 14 for D. Automatically, these two options are incorrect, totally incorrect. Okay, let's move to the next question, which is question number 5. Which description of brass is correct? Option A, alloy, alloy. Option B, compound. C, element, and D, non-metal. Okay, what is brass? Brass is a mixture of copper and zinc. When we mix metals together in certain proportion to produce an improved metal, that is what alloy is all about. Alloy. Therefore, the correct option here is A. And you should bear in mind that copper is an element, zinc is an element. Though both of them are elements, but this combination is simply based on a physical change. It is not a chemical change. Only a chemical change produces a compound, but this is just a mixture in certain percentage, a mixture in certain percentage of copper and zinc, producing what we call alloy. What we call alloy. So there's no production of new substance. Okay, then you will know what element is and you know what non-metal is. That's that for today. Join me in the next class. Please don't forget to subscribe, don't forget to like and share. Thank you for joining this class.